Hi guys, today I'm going to be looking at a situation where a car is driving off a 70 metre cliff at 100 kilometres per hour. Alright, so in this particular case, when we're looking at that, what we'll be assuming is the car is going horizontally there. It's going to follow a parabolic path and hit the ground. Now we know this here is 70 metres. Now it's always a good idea to picture what's going on, is in fact to draw a diagram of it, even if it doesn't ask you to do that. So here we know all the initial velocity is vertical velocity, and that's 100 kilometers per hour. Now if you do that on your calculator, 100, convert that to meters per second, divide that by 3.6, that will give you 27.78 meters per second. 27.78 meters per second. Alright, so if we start this question, so if we're looking to work out our horizontal vertical component, we don't need to use our triangle. We can just say our V vertical is equal to 0 meters per second, and our VH is equal to 100 over 3.6, which is equal to 27.78 meters per second. Making sure we've got our units on there. So that's pretty easy, the first bit. Alright, so our second part of this question would be to work out our time of flight. Now again, this is a bit like if we drop the car without actually having any speed, then it would hit the ground at the same time. Now from our starting position to where it finishes, we have a distance of minus 70 meters. Our initial vertical velocity is 0 times t minus 4.9 t squared. So this thing here goes out. I can rearrange this pretty simply. I get rid of the two negatives. T squared is going to be equal to 70 on 4.9 equals t squared. So therefore t is equal to the square root of 70 over 4.9. Now it could be plus or minus, but we know we just have to have positive times, so therefore we can do that calculation. 70 divided by 4.9, enter, that's 3.78. 3.78 meters, sorry, not meters, that's 3.8 seconds. Change that to minutes. Alright, so that's our time. To work out how far it will actually land from the cliff, right, we know our time of flight, we know our horizontal velocity. So our SH is going to be equal to 27.78 times by 3.78, and that will work out what our range is. So 3.78 times by 27.78, 105 meters. Okay, 105 meters. Fair way. What sort of velocity is it going to have when it hits the ground? Again, that's something we need to work out. Now we know the horizontal velocity is going to be 27.7. We need to work out our vertical velocity equals v0 plus 8 v times by t. In this particular case, we know that's equal to 0. It's going to be simply minus 9.8 times by the time of flight, and that was 3. Brain's gone dead. 3.78, and that will give me my vertical velocity. So therefore, so 9.8 times 3.78. And that's going to give me an answer of 37 meters per second. So 37, it's going to be minus meters per second. So again, we can work out our velocity by knowing that it's the horizontal velocity, which is 27.78 squared plus 37 squared. That will give us our velocity. Our angle is going to be equal to inverse tan of the vertical velocity, which is going to be 37, divided by 27.78. Alright, so let's go and do that. So if we do the Pythag first, so 37 squared plus 27.78 squared. Alright, it's going to give us an answer of 46.3. 46.3 meters per second. And then to work out our angle, so inverse tan of 37 divided by 27.78, and that's an answer of 50 degrees, 53 degrees. So therefore, velocity on impact is 46.3 meters per second. Now you could convert that to kilometers per hour if you wanted to, at 53 degrees below horizontal. So you give the direction as well as the speed. Now the last part of this question, which is to find the maximum height, well, the maximum height is going to be what it's launched at, so that makes sense in this question. So we'll just leave that there, and that's really basically what we have to do with this sort of question. So horizontal one probably becomes a little bit easier, simply because we don't have to use our graphics calculator to find time of flight. Again, you should be looking at this stuff over here in this box, because that gives you a bit of an idea about the sort of things that you would be expecting. The one that we're looking at in this particular case is this one here. Right, so that will help you, I hope. Well, so we'll talk to you very soon in the next video.